Hello guys, I prepared here a little experiment and it is designed to demonstrate what a carrier wave is. I need that example for my coming videos so that you understand what I mean. And this is a audio amplifier, this is a signal generator. That's the battery feeding the signal generator. That's a power supply for the audio amplifier. Here's a part we will use later that is not used already, and a loudspeaker. And first of all I will generate a tone. I plug it on and give it a tone. A bit louder. Here's the frequency generator. And the next step will be that I disconnect the loudspeaker and give that tone on an oscilloscope. That part here. Here I connected the scope and you see the waveform on the display. When I make louder or less loud, you see the changes. And here's the frequency changes also. This, by the way, is not a very fine-tuned sine wave or something. It's a very simple frequency generator. So it aims more at a square wave, but doesn't matter. A wave is a wave. Okay, that's the basic. We have here a wave, and what I want to show is you can use that wave as a carrier wave that carries another signal. For that reason I tuned the scope in a way that you can see the waveform, and you will see the peaks and the valleys. I now modulated the waveform with a signal that is generated here from the basic low power AM transmitter, and it generates a carrier wave upon which the tone, the signal I generated before, is put upon, so to speak. So we have the wave and it has some edges. And the waveform is generated by the low power AM transmitter, and the signals on it that are traveling across the wave, this is the tone you heard before that is generated from the signal generator. Try to make it a bit better, yeah. Now you see the spikes here along the waveform. Now I add a demonstration how this basic low power AM transmitter here, this one, generates a signal that is kind of sine wave. You see that sine wave on the scope. There is some background noise on it, and I can also change the waveform when I put my hands near, because of the inductance here of the coils. When I now connect it to the audio signal, you see how that signal travels along the waveform, alongside the waveform. So I keep it connected, have it here on the input, and now I change the volume, make it louder, and you see the waveform that is generated by the basic low power AM transmitter, it stays the same. That's a sinus wave, but on it or alongside it the signal is carried from it. And now I change the frequency. And you see the frequency changes appear also here on the waveform. And you see even the edgy nature of the signal itself, because it's not a sine wave. So you see both waveforms at one time. You see the sine wave that is generated from the AM transmitter, and you see the more edgy signal traveling on it. Just wanted to add that because the pictures weren't that good in the clips before, but I just want to make clear what a carrier wave is and how it works, because we use that principle in radionics and it is very important to consider. Of course, you can make these paper devices or chemical kind of devices, and you don't really work with a carrier wave, you just work with your mind or spirit. And the difference I want to point out is that you can apply a physical principle into the mechanics of a radionic device, because this is all electromagnetic stuff. You see, it's all fed with power supplies. You have a frequency generator, and this principle is based on electromagnetic energy. Now, many people say that radionic devices do not work on electromagnetic energy. There's something else at play here, and I want to, somehow with that video to bridge that discrepancy between the electromagnetic approach and other approaches, like that of T. Galen Hieronymus, who used a prisma inside of a radionic device to use that prisma for a carrier wave. That prisma could be tuned by an electrode. You could tune the electrode into a specific color wavelength and use that as a carrier wave for radionic signals. And I would say that a color spectrum or color wave is not electromagnetic in nature. It is more in a state where it doesn't really know what it is until the operator comes and tunes it into a certain signal. So I would say it is not an electromagnetic signal, but the principle I want to show here is the same. So you can basically tune, like I tune here, the frequency. You can tune that with color on a Hieronymus machine, and the color is then the carrier wave. And it transports the information. So when I have the carrier wave and I tune the frequency here, that's the information I send over a radionic machine. And the carrier wave that is generated by here, that is the frequency band or the color band, the color range that the prisma emits to the electrode. And I will point that out later. Thanks for watching so far, and bye bye.